A few people are going to join us later. We're going to get started right now with our Chapter 10 series prep. Hope you enjoyed this webinar and this presentation. All right, so first up, test format. We talked about this on the study guide, but it is 8 multiple choice and 5 open-ended, and it's a full period test. Calculator is allowed on all of it, though not all the questions require a calculator, and not all of them will help you if you have a calculator. You just got to know your stuff. I broke the series stuff down into 4 main categories on the study guide, and you could check that out for more information. Just to give you a little insight on how I make the test, because as you know, a lot of the test questions we use are straight up from the AP practice, and this is my desktop. I took a full screenshot from it today, and all these screenshots that you're seeing, those are actually little cut and paste screenshots I've taken from previous AP test sections. Now, you might be wondering, oh, well, can I Google them? And unfortunately, no, these are multiple choice sections that I have access to as an AP teacher. You do not, but I can assure you I looked at the 2014, 15, and 16 tests, or practice tests put out by the College Board, and I cut them up, took all the series questions, and you're going to get a mix of those on your test on Tuesday. All right, so let's do a brief review of a couple things, just a couple tips in this webinar. There are 3 remainder formulas you need to know. So there's the geometric series, the alternating series, and the Lagrange formula. For geometric series, remember there, the idea is you're going to write out the series, truncate, and then create a new series with the remaining terms, and then you use that A over 1 minus R formula to write a formula for the new series. Okay, geometric series are the only series we know how to find the sum of, and that total sum is A over 1 minus R. Second, for alternating series, if it fits those criteria for the alternating series test, where the signs alternate, the limit of the nth term is 0, and the terms decrease in absolute value, then we can say that the error, whatever that error is less than the n plus first term. So if it's an alternating series that fits those criteria, you don't have to use Lagrange to bound the error. You could say it's less than the n plus first term. And then third, everyone's favorite, for any Taylor polynomial, we know that the error is less than, and then this is the Lagrange formula, I should say the error is exactly equal to the n plus first derivative evaluated at c times x minus a to the n plus 1 over n plus 1 factorial. Now, it's directly equal to this, but then the whole idea behind this is, well, we don't know exactly what the c is, but we know that c is between x and a. So I could say c is between, I don't know which is bigger, x or a. That's why I don't want to write it in inequality form. Whatever x and a are, c is between those. So that gives us a range for our c, and then we can pick the one that's the biggest, and then the goal will be, well, can we bound this using a formula for c? Sorry, 1 second, I just lost connection with my mouse. 1 moment, please. So you would choose a c that will make that fraction the largest, and then you could say, okay, this would be the bound for our error. Okay. Okay, just 1 moment, please. Sorry. Technical difficulties. I'm going to plug in a backup mouse that I have. I'm not getting connection with this one. Sorry, just give me 1 minute. Sorry for the delay. And we will continue shortly. Okay. All we're back in business. So the idea is that this will be less than some quantity that you find by plugging in a value here for C and bounding this whole thing. So you have to find an expression which is like this expression, but this term, we're going to pick a C, or pick a number rather, that we know will maximize this term. So it'll end up being something, whatever this is. And if you watch my other video, you get some more details on examples here. And then x minus a to the n plus 1, that'll all stay the same over n plus 1 factorial. It's possible you'll have to bound the x minus a term as well. There was one example like that in class. Okay, heading back to here, and we're going to have an option for some board points in a moment. So hopefully you can find that chat box. Some other quick tips. You do need to know the 6 series that you're supposed to memorize for the AP test. So those are listed on your study guide. You may need them to build a series, but you also may need to differentiate or integrate them if you're asked to find a series that's actually the derivative of one of those or the antiderivative of one of those. Second tip, when you're looking to use limit comparison test or comparison test, and Andrew brought up a good question about this today. If you're comparing with limit comparison or comparison test, you always basically want to pick a P series. Okay, the reason you want to pick a P series is it's very easy to know if the P series converges or diverges. If it's harmonic, if it's 1 over n, we know it diverges. And then if that P is anything less than 1, we know it diverges. And if that P is anything greater than 1, we know it converges. So we can use that rule very easily for a P series. So by comparing to a P series, we'll be able to tell what our function will do, or what our series will do. Third, if they ask you to find the sum in a problem of an infinite series, the only one we know how to find the sum of is geometric. So that should be a dead giveaway. If they're asking you for the final sum, not a partial sum, but the final sum of an infinite series, then it has to be geometric, and you're going to have to use that a over 1 minus r formula after making it clear what the common ratio is and what that a value is. All right, now partial sums you can do for any, but final sum of an infinite series you can only do for geometric. Lastly, if you notice something has increasing powers of x, like the powers of x increase by 1 each time and the coefficient changes, then you can use the ratio test. Okay, power series are best suited for the ratio test, which we did in class several times, and that'll give you the radius of convergence as well as information to find the interval of convergence. You'll then have to test the endpoints, but that's the basics of what happens there. I didn't put number 5 on here, but number 5 is obviously you got to know your flow chart. Section 10.5 had you doing a bunch of tests and trying out a bunch of things to see if things converged or diverged, and you got to use the flow chart to make that happen. Did the remainder formulas, oops, going backwards here, sorry. Okay, so the next slide I have a multiple choice question, and here's how this is going to work. The first person to produce the answer with justification in the live chat will receive a board point. And without further ado, here is our first multiple choice question of this live webinar. Take your time, read it. And if you have an answer with justification, you can post that right in the live chat. It doesn't have to be super long on the justification, but if you can explain your answer, that will get you full credit. And we'll just put a time limit on it. If nobody gets in about 3 minutes, then I'll just explain the answer. And those of you who are watching the replay, you can tune in for that later. So right now we are waiting on a first answer to the multiple choice board point question. And if you're just joining us, then to the right of the YouTube window, it should say live chat where you can type, or it also should say show chat in the top right. And if you have trouble finding that, you can send me an email and I can check it. We'll just wait another minute to see if anybody can solve this problem. All right, Julia has joined us. Thank you, Julia, for finding the chat box. Great to see you. All right, Alex has presented an answer. D, because the series converges since the limit of the ratio is less than 1, and you're using a over 1 minus r to get 32. And Alex, that is precisely correct. So in this problem, you get a board point. They're saying that the first term of the series, they tell you a sub 1 is 16. That's the first term. And then this presentation here of a to the a sub n, of the n plus 1th term over the nth term is a half. That's another way of saying the common ratio is a half, because if you take any term and divide it by the previous term, you get a half. So that means we use a over 1 minus r, where the a is 16 and the r is a half. And if you do that, you do get d, which is 32. So nice work, Alex. But now we're going to have a second question for a board point. All right, so here's number 2. Practice multiple choice for series test. Oops. Okay, good luck. And the goal is you got to be the first with the correct answer and sufficient justification. Okay, and Eric has sent me an email saying he doesn't think you can comment without a YouTube channel. So that might be why others are failing to comment. Can you make sure, I'm just going to say, can you make sure, Eric, if you're there, if you can try logging in to make sure you're logged into Gmail, and then make sure you are on the YouTube live page, and then you should be able to comment. But if not, maybe Alex or Julia can send us a quick email or send somebody a quick, or just give a quick message of how to focus on this question first. If you're working on the question, keep working on it. But if you need to figure out how to type in the chat box, I'd like everybody to be able to do that. So perhaps Eric is right. I'm going to look into this right now as you're all working on this question. Do you need a YouTube channel to type in a YouTube live chat box? To type. I'm looking into this question, Eric. Thank you for sending me an email. Okay, how to live chat. I got a help page here. Only exists on YouTube watch players, watch pages. Okay, you know what, Eric? I think we're getting some help from Julia here. And as always, the first time we do it, we need a little bit of support, and there might be technical difficulties. Okay, Julia says, Alex showed me how to do this. On the YouTube window, click on the little green circle with the person inside it. Then it will prompt you to make a channel with your student account. So HPREG basically gives each student his own channel, but he has to make it. Okay, thank you, Julia, for the help. Where again is the little green circle? Because I don't see a little green circle, but perhaps it's because I already have an account. Oh, the top right of the screen. Yes. Okay. So where your login name is in the top right. Thank you. All right. So Eric and others, why don't you try that? And you just have to, it looks like you just have to enable your own channel, and then you should be able to type in the chat box. Okay. And Alex has given an answer here. I think it's E because the terms increase. Okay. I will say that is not correct. So we're still waiting on a correct answer here with some justification, either from the notes or from the book or something that you know. And hopefully Eric and others who are watching, if you looked at Julia's instructions, you want to click on the top right circle of your account, and then you want to make a YouTube channel. But perhaps some of you are struggling with that, so you may need to. All right, Alice just made a channel. Thank you. Great work, Alice. Okay, Julia says A because that's where the series goes as n approaches infinity. That is correct. And let's talk about that a little bit more deeply. So Julia, you get a board point, and Alex has secured a board point. And perhaps there'll be some more board points for those of you just learning how to work in the chat. But notice they're not giving you any information about the nth term, or they're not giving you a formula, rather, for the nth term of the series itself. They're not giving you a formula for the series. We don't know what this a sub k represents, but they are telling us about the partial sums. Okay, and this is a technical point, but it's important. We learned actually back, I believe it was 10.1, I could double check, but the limit of partial sums, the limit of the partial sums, whatever value that is heading towards will be the sum of the series. So the crucial idea here is that we are talking about partial sums. We're not talking about the formula inside the series itself. So wherever the partial sums are heading, which normally you don't know it, it's not always obvious what that is. It's just here they gave it to us. They're saying the partial sums are heading towards this expression. That's the formula. And so whatever the limit as n goes to infinity of partial sums is, that's actually the sum of the series. That's where the full series is going. So the correct answer is 1/3 A. So Julia, that is correct. Okay, hopefully some more folks can join us here as we move on to a little more information about what we're going to do tomorrow, and then I'm going to open it up to your questions. So tomorrow in class, you're going to see more of those multiple choice questions. I showed you my desktop earlier in the presentation. There's a lot of problems. I'm going to pick a good 5 or 6 that we're going to do in a Kahoot. And then you'll see, obviously, 8 questions on your actual test. So first we'll do that Kahoot practice multiple choice. Second, we will go over that sample FRQ on the study guide. So if you haven't had a chance to attempt it yet, I would work on that tonight, and I'll take questions on that tomorrow in class. And then with any remaining time, we'll take questions and answers on anything you didn't have a chance to ask tonight or something you get from studying tonight. Okay, so now it's time to throw it over your questions and answers. I'm going to look at the chat box and see what you have as far as questions. And I'm going to toggle over to Sketchpad here, where I can make a new page and draw as we talk about these math problems. So let me just also scroll up and check Julia's. Thank you, Julia, again, for posting this method. So in order, if you haven't been able to figure out how to do the chat yet, because we're not using Google Docs, we're using a chat box, you have to click on the YouTube window or scroll up in the chat and you can read the, well, you can't see the chat yet. So Julia explained how to do it. Actually, you know what, Julia? Let me just copy and paste what you said into a brief email for the class. I hope you don't mind that, but I realized if they can't see the chat box, then they're going to have trouble figuring out how to do this. So for those of you wondering how to do this, Eric and others, I just sent a quick email copying, pasting what Julia said in the chat box that explains how to do it. Okay, it says there's 7 people watching now, and Julia has offered a first question for set B2, number 42. And I assume you're talking about 10.5, the most recent homework. And we can look at that together. So let me just open that up. And this is number 42 on set B2, which is section 10.5. And we have, okay, we're finding interval convergence and absolute versus conditional convergence. So let's look at that together. We have n going from 0 to infinity. This is number 42. And we have x to the n plus 1 over n factorial. I'm sorry, x to the 2n plus 1 over n factorial. Okay. Power series. So we know this is a power series because if you plug in 0, you'll get x. And then if you plug in 1, you'll get, well, actually, no, if you plug in 1, you'll get x cubed. So yeah, it's not a power series that hits every power of x, but it does have increasing power of x, increasing powers of x. So it is going to be primefully a relevant candidate for the ratio test, especially when they ask you for interval of convergence. That's what you want to think about when you have increasing powers of x. We're going to use the ratio test to try to figure out what we got here. So let's consider the limit as n approaches infinity of the n plus 1th term over the nth term, absolute value. So we're going to have here x to the, and remember we're putting an n plus 1 here, so that will become 2n plus 2, which when you simplify it, that's new exponent is going to be 2n plus 3 over n plus 1 factorial. So in this n, I put an n plus 1, and that's how I got this new exponent. Then we're dividing by the nth term, which we'll multiply by the reciprocal. And we have x to the 2n plus 1. And that's the limit we need to take. Okay, that makes sense so far? Well, I'm just giving some time for others to join us as they might have questions. They might be figuring out the YouTube Live account. I just sent out an email that explains how to do it. Does that make sense so far, Julia? Okay, so let's keep going. Next step is to simplify. So let's see what we got. We got n plus 1 factorial here, and as Chris pointed out in class, n plus 1 factorial and n are going to cancel out such that you have an n plus 1 in the denominator, and in the numerator, just think we're subtracting these exponents because they're both powers of the same base. When you divide, you subtract exponents. So we obtain x squared. Ah, this is nice. Okay, so I don't think we saw one quite like this in class. There might have been one that was similar, but not exactly. As you can see, n is going to infinity. We don't know what x is. We actually have to suspend judgment, but we know, x we want to find. It could be any real number. We want to find which real numbers it's going to be convergent for and which it's going to be divergent. And the question we have to ask ourselves is, when is this less than 1? Not question mark, sorry. When is this thing less than 1? And as you may have already recognized from what I'm hinting at, since x is going to be a real number and the denominator is going towards infinity, this limit is 0. No matter what real number x is, this limit is 0. So that's for all values of x, which means that this series converges for all real numbers. So the answer to A, when it says, What's the interval of convergence? You can do negative infinity to infinity, or you can write all real numbers. That's fine. It says, what does it converge conditionally or absolutely? Well, we didn't use the alternating series test. So it converges absolutely for everything, and conditionally is none, because that means we arrived at it using the alternating series test. That's how to do 42B. Okay, so hopefully that helps. And I'll pause for a moment, see what questions you have. Any other questions on problems where you had trouble? And if you're really struggling with the chat box, you can send me a question via email. I do have my email open on another screen, so I can see that live. So if you send me an email question, I'll keep refreshing it. I can look at questions that way. Okay, what other questions do you have on 10.5 or the study guide in general? Thanks again to all of you who are joining. I hope you find this useful, at least the practice multiple choice and the quick tips. Hopefully that was helpful. Okay, thank you, Julia. And again, I'm letting Julia ask another question in a row, but if you have a question, just throw it up there and we can talk about it. And if you have another question, Julia, then you can keep asking away. But if others have a question, I will let them go first, and that's not a problem. You can always email me a question if you can't find the chat box. Okay, number 30, 10.5. Okay, so same section. Number 30, determine whether it converges absolutely, conditionally, or diverges. Okay, give reasons for your answers. Okay, number 30. So, right away I'm ruling out conditional convergence because this is not an alternating series. So I'm not going to use the alternating series test. Okay, so therefore anything we find is going to be either be absolute convergence or divergence. So this was a good one that you asked, Julia, because it gives us an opportunity to go through the flow chart together. What would be your thought process if you got this series on the test? The question is, converge, diverge, what does it do? So how can we tackle this using our flow chart? Okay, flow chart says first check the nth term. Does it go to 0 as n goes to infinity? If not, we have automatic divergence. So checking the nth term, think, if n's going to infinity, this denominator is getting enormous. This numerator has to oscillate between -1 and 1. So the nth term does go to 0. Therefore, the nth term test is inconclusive. We don't know if it diverges or converges because it went to 0. Secondly, is it a p-series? No, it's not a p-series. Oh, sorry, the second thing is actually geometric. Is it geometric? No, it's not something raised to the n. So it doesn't have that form of a plus ar plus ar squared. It doesn't have that form. So we can't use the geometric judgment. All right, I should probably put an X here. That test didn't work. This test didn't work. And p-series, no, it's not an exact p-series. All right, so if those three quick ones fail, then you either have to try a comparison test or the integral test or alternating series test. Alternating series test or ratio test. I'm sorry, ratio test is in there too. Alternating series test is out. I'm thinking this is primed for a comparison test with a p-series. So this expression, as n goes to infinity, where is it headed? Well, that numerator is toggling between -1 and 1. That denominator is getting huge. So this thing is going to kind of, at its end behavior, it's going to look a lot like this p-series. In other words, I'm going to compare it to 1 over 3 squareds. Sorry, 1 over n to the 3 halves. 1 over n to the 3 halves. Okay, so let's compare it to that. And by compare, I'm going to use the limit comparison test, where you actually take the limit of the two series divided. And since their end behaviors are close, I actually expect this limit to be a constant, which would mean they both do the same thing. But to be sure, let's do it correctly. I'm going to take this first one and divide it by the second. We have cosine of n pi divided by n to the 3/2. Steph Plaza did a similar simplification in class with these powers. I remember that. And then we're multiplying by the reciprocal of this. We're dividing by this, but to divide, we'll multiply by the reciprocal. And then we have that. Okay, and then these are going to cancel out. So we have the limit as n goes to infinity of cosine of n pi. All right, so unfortunately, limit as n goes to infinity of this, and this actually does not exist. Or, think about this for a second. So we have n pi. I mean, I want to say it's tiny. Yeah, technically that does not exist because n is this value is oscillating, so we can't say it equals 1. Okay, so that limit comparison did not help us, but perhaps the direct comparison will help us. Okay, yeah, because if the limit does not exist and tends to an infinity, or if it goes to 0, that's one thing, but here it just flat out does not exist because it goes -1 to 1. So how about a direct comparison? Can we say anything about this series compared to this? Well, what do we know that this does? Let's think about this one for a second. As n goes to 1 for infinity, we know that this since 3/2 is greater than 1, this series will converge. Oh yeah, okay, there's the argument. Hopefully some are seeing. So you know what, I went with the limit comparison. Typically, I kind of like doing the limit comparison. In this case, it didn't work. But here the direct comparison test is going to be nice because, as you may have noticed, direct comparison test, what's the most cosine can be? The greatest cosine can be is 1. So we can state with certainty that the cosine of n pi over n to the 3/2 is less than or equal to 1 over n to the 3/2. So if this one is less than this one, and we know this series converges, then therefore we can conclude that this series also converges. So let's see if I can get a text box. We can do our final answer like this. We can say since P series converges, original series is less than or equal to it. I'm just being a little, I'll write it out. Or equal to it. The original series also converges. To be precise, I should say the original and the terms of the original series are less than or equal to. That's what I did with this inequality, but if you're writing it out in words, less than or equal to the terms of the P series. The original series converges. Okay. All right. So that's a good example of the flow chart. You know, sometimes you'll try the quick ones, they won't work. You'll try a comparison test and you might get a dead end, and you might have to try something else. And in this case, we were able to reason through the direct comparison test. Okay, Julie said that makes sense. Oh, but you had another question. If it does not exist as a dot now, we can't conclude that. The limit comparison test, you do need something certain to happen. It either needs to diverge to an infinity, it needs to equal 0, or it needs to be a constant. But that one flat out did not exist, so that would actually be inconclusive. Okay. What other questions? So we still have at least 10 minutes left in our webinar. I'm going to check what's going on the email front. No questions by email, so I will open up the chat if anyone has any additional questions. We'd gladly go over those. And if you hadn't had a chance to study yet, I would study these problems tonight, complete your homework, and we'll look at some more practice tomorrow in class. So any other questions? Going once? Oh, okay, Mr. Mayetta. Yes, number 46, 10.5. Let's do it. This also looks like a power series. So power series, I tend to deviate from the flow chart, and I just think ratio test when I see a power series. Let's take a look at this guy. Yeah, n goes to 0, or sorry, from 0 to infinity. Okay, this is actually a power series, increasing powers of x. So we're going to look at ratio test, and then we can determine interval of convergence and absolute versus conditional. So let's check the limit of the n plus 1th term over the nth term, absolute value. And we'll have n plus 1 factorial and x minus 4 to the n plus 1 over n factorial and x minus 4 to the n. Simplify. This becomes the limit. And Alex, just let me know if something doesn't make sense so far. You can type it right in the box. But you cancel these out like as we did before, and you obtain the term n plus 1 times x minus 4 in the numerator. We have absolute value. And this one does look very similar to one that we did in class, because this whole expression looks like, because of this n here, there's no denominator, going to infinity, looks like the whole thing is going to go to infinity. And we have to ask the question of when is it less than 1? And it doesn't seem that that's possible, because no matter what number you choose for x, it seems like this whole thing is going to go to infinity unless x is one special number. So we can declare that this thing is less than 1 if and only if it's less than 1 only if x is 4. Okay, so that would be the answer to your question here. The interval of convergence is simply 4, or you might write it in set notation, the set of 4. Just that number is the only time it converges. It does converge absolutely at x equals 4, because we did not arrive at that using the alternating series test, and conditionally none because we didn't use the alternating series test. Okay, so this is what we can say for number 46. All right, Alex, hope that helped. Anyone else have a question? Going once. Refresh the emails. Okay, Julia, thank you for specifying this one. Number 23, especially the part about the truncation error. Let's take a look at that one. Okay. So this is a alternating series. I'm just trying to take a look at this one. Okay. So as far as truncation error, do you want to talk? The answer to the convergence divergence question is on the Google Classroom under 10.5 B1. But let's tackle that special part about truncation error. And if you want me to go back to convergence divergence, that's fine. The textbook version is they ended up using a comparison test with the p-series, and that's how they found it converged. Okay, but if we have to find a bound for truncation error, then we have 3 ways of doing error, and we can consider this together. Okay, let's look at this together. So we have 1 plus n over n squared. And we want to find a bound for the truncation error after 99 terms. So after 99 terms are used, what is the error going to be less than? How good is our series going to be? Or how close is it going to be to an actual value after 99 terms? Okay. So the idea is here, since it's alternating, you only have 3 options for error. Either it's geometric, it's alternating, or it's Lagrange. It's not geometric, it's not something raised to the end, and it is alternating. So we'll use that test. To check that we can apply this, we see if the terms are decreasing in absolute value, and they definitely are. As this n increases, n squared is going to be much bigger than 1 plus n. So that limit's heading towards infinity. Sorry, that limit as n goes to infinity is headed to 0, and the terms are decreasing in absolute value. So the alternating series test says the error is less than the n plus 1th term. Okay, so in other words, we know that the error is less than the 100th term. When you've used 99 terms, the error has to be less than the 100th term. So we simply have to do less than -1 to the 101 times 1 plus 100, or 101, over 100 squared. 100 squared. Okay, that's the n plus 1th term. And so you can evaluate this in a calculator, and you'll get approximately 0.0101. Does that make sense? Oh, Elton has found us. Excellent to see you there. Really, does that make sense? You just have to evaluate the next term. If it's at 97 terms, you would look at 98 and plug it in, use a calculator for that portion. But that's actually a good thing. I mean, think about how much easier that is than Lagrange. All you have to do is plug in 1 term. So geometric and alternating are great. Lagrange we do have to be ready for as a last resort if it doesn't fit either of those types. Okay, so we are at our 8 o'clock stop time, but I can do one more question, maybe from someone else who hasn't asked one yet. Otherwise, I'll just save it for a little bit of extra help tomorrow after school. If you want to show up for extra help, I can stay till about 3:20 tomorrow, and then I can also come in Tuesday morning if you have some additional questions, or you can send me an email. So any other questions going twice? Okay, so then I will say sold. Thanks for watching. And I'm going to post this onto our Google Classroom, and I'll say bring questions tomorrow based on your study, and we'll do the 3 things I said before. We'll do a Kahoot, multiple choice. We'll go over that open-ended on the study guide, and then lastly, we will take your questions. Have a great night. Bye, everybody.